Hi there. Today we're going to look at Hubble's law, or Hubble's constant. Back in 1929, Edwin Hubble, using the observatory at Mount Wilson in California, their 30 and 60-inch telescopes, observed a relation between the distance and the receding velocity of galaxies, what we call Hubble's law today, and in so doing he unveiled the expanding universe and forever changed our understanding of space. It's hard to imagine, but only 90 years ago, we didn't know about the existence of the majority of space. Back then we thought that all there was one galaxy. And what we now know are other galaxies, they refer to those faint patches of light as nebulas. They didn't think of them as other galaxies because they didn't have the technology to see them. Hubble showed that galaxies are moving away from us with a velocity that's proportional to their distance from us. The further away the galaxy, the faster it's moving away. This is called Hubble's law, and you can see a graphic representation here. It indicates the expansion of the cosmos. The slope of the relation, HO, is the Hubble constant, and it represents a constant rate of cosmic expansion caused by the stretching of space-time. And although the expansion rate is constant in all directions at any given time, the rate does change occasionally. Hubble's remarkable observations were recorded using 24 nearby galaxies because he could measure their distances accurately as well as their velocities. And most of the velocities were recorded using redshift observations from the astronomer Vesto, Melvin, Slipher, using a spectroscope. For more information on that, have a look at our video on redshift. Over the following years, using much more sophisticated equipment, many observations have been made, which all show Hubble's law was right. However, Hubble's values for his distances were wrong by a factor of about 7. So all the distances were too small by a factor of 7. And the expansion rate of HO was too large by the same factor. Hubble's factor for HO was 500 kilometers per second per megaparsec, whereas today we know it is actually 70 kilometers per second per megaparsec. A megaparsec is 31 trillion kilometers. However, despite the difference and its implications for the expansion rate and therefore the age of the universe, Hubble's fundamental discovery of the expanding universe is not affected. Hubble's discovery portrays an amazing scientific tale because his distances had a huge error by a factor of 7. Yet his result of velocity versus distance relation changed the course of science by revealing an expanding universe. And Hubble's law, the constant, the Hubble time, and the more recently Hubble Space Telescope are just tributes to this awe-inspiring discovery by this man. The science of cosmology would not exist were it not for Edwin Hubble. And for that we owe him a great gratitude. Well, I hope you enjoyed that short video looking at Hubble's law and Hubble's constant. It's not that difficult to understand once you get your head around the numbers. Basically, at the bottom line, the further an object is away from us, the faster it's moving away from us, the greater its redshift. Well, take care. I'll speak to you next time. Thank you for watching, and bye for now.